In this video, we'll solve some more problems on piecewise defined functions. Here's the first one. Find the relationship between a and b such that the given function is continuous at x equals to 3. So we're given that the function is continuous. Now we need to find some values of some variables. Here's the function. Fx is equal to ax plus 1 when x is less than or equal to 3 and bx plus 3 when x is greater than 3. So this is a piecewise defined function defined in two parts. The first part is for x less than or equal to 3. The value here is ax plus 1. And the second part is for x greater than 3. And the value here is bx plus 3. A and b are hidden here in these definitions. So we need to use this information that the function is continuous at x equals to 3 to figure out the relationship between a and b. Pause the video, give this one a try. Okay, let's do this together. So what should happen for the function to be continuous at x equals to 3? Well, the limit should be equal. The left hand limit should be equal to the right hand limit, and these should be equal to the value of the function at x equals to 3. So left hand limit equals to right hand limit equals to the value of the function at x equals to 3. When this happens, the function is continuous at x equals to 3. So we'll use this to form equations and use those equations to find the relationship between a and b. So let's do that. Let's find these limits. Limit x tends to 3 minus, which is the left hand limit of fx. So this is going to be x tends to 3 minus, and for the left hand side, we'll use this definition, ax plus 1. So let's plug in 3. This is going to be 3a plus 1. What's the right hand limit? X tends to 3 plus fx. For this, we'll use this definition, bx plus 3. So that's going to be b times 3 plus 3, that's 3b plus 3. All right, we have both these limits. Both of them have to be equal. So that's our first equation. But let's also plug in f of 3. So f of 3 is 3 times a plus 1. So when x is 3, we'll use this one because this says x is less than or equal to 3. When x is 3, we'll use ax plus 1. So 3 times a plus 1. So what we got from here is the left hand limit, that's 3a plus 1. That's equal to the right hand limit, that's 3b plus 3. That's equal to the value of the function at 3. That's 3a plus 1, but we have already taken 3a plus 1, so we don't need to write it again. So 3a plus 1 equals to 3b plus 3. That's the relationship that we're looking at. If you want to simplify it, we can write this as 3a equals to 3b plus 2. 1 goes here, 3 minus 1 is 2. So this is the relation between a and b. Whenever this happens, this function is continuous at x equals to 3. Let's solve one more. Find the values of a and b such that the given function is a continuous function. The function is a piecewise one. It's defined like this. Fx is equal to 5 for x less than or equal to 2. It's equal to ax plus b for x between 2 and 10. And it's equal to 21 for x greater than or equal to 10. A and b are here. So pause the video. Try finding the values of a and b. All right, let's do this together. The function is continuous, but it's always continuous when it's a constant function. So we'll get nothing out of these definitions independently. But if we check for points where the definition changes, that's where we'll get the equations which we can solve to get a and b. So we'll get two equations. One when we check for x equals to 2, and the other one when we check for x equals to 10. So we're given that the function is a continuous function, which means it's continuous at x equals to 2, and it's also continuous at x equals to 10. So if it is continuous at x equals to 2, this means the left hand limit is equal to the right hand limit is equal to the value of the function at x equals to 2. We'll get our first equation here, and we'll do the same thing here. The left hand limit at x equals to 10 should be equal to its right hand limit should be equal to the value of the function at x equals to 10. All right, let's try solving. The left hand limit at x equals to 2. If we look at the definition, for all values less than 2, the output is 5. So that's our left hand limit. So that's 5. The right hand limit at x equals to 2, we'll get it here. Ax plus b. So a times 2 plus b, that's 2a plus b. And what about the value at 2? That's here. X is less than or equal to 2. So that's also going to be 5. So the first equation is 5 equals to 2a plus b equals to 5. We don't need two 5s. We can just use the first one. So 5 equals to 2a plus b or 2a plus b equals to 5. This is our first equation. we'll get something from here as well. Let's do that. Left hand limit at x equals to 10. We'll get that from here, ax plus b. So 10a plus b, that's our left hand limit. Right hand limit is 21 because it's 21 for all values that are greater than 10. So that's 21. It's also 21 for x equals to 10, which means f of 10 is also 21. So our second equation is 10a plus b is equal to 21. So two equations, two variables, let's solve them. Subtracting one from the other, we'll get 8a equals 21 minus 5, that's 16. So 8a equals to 16, divide this by 8, we get a equals to 2. When a is 2, 2 times 2 is 4. Putting it here, we'll get 5 minus 4, that's 1. So b is equal to 1. So when a is 2 and b is 1, this function is continuous throughout. So our values are a equals to 2 and b equals to 1. Let's solve one more. Find the values of lambda such that the given function is continuous at x equals to 0. And the function is defined as this. Fx is equal to lambda times x square minus 2x for x less than equal to 0 and 4x plus 1 for x greater than 0. Pause the video, try this yourself. Okay, so if the function is continuous at 0, this means its left hand limit is equal to its right hand limit is equal to the value of the function at x equals to 0. So that's equal to f of 0. So let's find these things and equate them. So the left hand limit at x equals to 0 will come from here, will come from this definition. So we'll put in 0 here. That's lambda times 0 square minus 2 times 0. Wherever we have x, we put in 0. The right hand limit will come from here. That's 4x plus 1. So that's 4 times 0 plus 1. And the value of the function will come from this definition, the one above this. That's lambda times 0 square minus 2 into 0. So that's same as your left hand limit. So let's simplify. Lambda times 0 minus 0. There are a lot of zeros here. So 0 minus 0 is 0. So lambda times 0 equals to 4 times 0 plus 1. That's 1 equals to, again, this is lambda times 0. So this is a bit strange. We're getting 0 equals to 1. Lambda actually gets cancelled out because it's being multiplied by 0. So this is saying that it's continuous at 0 when 0 is equal to 1. So when this happens, this function is continuous at x equals to 0. But this never happens. It's never the case that 0 is equal to 1. This means this never happens. This means the function is never continuous at x equals to 0. So no value of lambda can do the job for us. So our answer is this lambda belongs to phi, the empty set. There is no value of lambda such that the given function is continuous at x equals to 0. What about some other point? What about x equals to 1? What value of lambda should we place here such that this function is continuous at x equals to 1? Pause the video, give this a try. Let's do this together. 1 lies in this interval, x greater than 1, and lambda is not touching this interval. The definition is 4x plus 1. It has nothing to do with lambda. So no matter what you do, your function is always 4x plus 1. And since this is the polynomial, it will always be continuous. This means this is true for all values of lambda. No matter what you put, any real value of lambda will work. This function will always be continuous at x equals to 1. Here's how we can write this down. This is the left hand limit at 1. It's equal to the right hand limit at 1. It's equal to the value of the function at 1. All of these values are 4 times 1 plus 1, that's 5. 4 times 1 plus 1, 4 times 1 plus 1, and 4 times 1 plus 1. So 5 is equal to 5 is equal to 5, irrespective of what your lambda is. So all values of lambda work. So here the answer is lambda belongs to the set of all real numbers.